Hello, so today we are going to talk about caching in Angular. So we're gonna read an article. First, this article is titled "Avoid Cache." Oops, so big. Cache trap when, oops, when serving Angular app. Okay, so how can we avoid cache trap when serving Angular app? Okay, so let's read. What is the weirdest bug you ever got? One of my top 10 came after a major design change we made. I open the app and I'm getting a blue design. After I'm doing a refresh, I'm getting a dark design. And that is happening every morning. Every morning? What in the world? So, since you have the title of this article, you already know this one is related to cache. But why is this happening and what can we do to prevent it? We all love cache. I think it helps to load our apps faster, lower some load from the server, and allow users uh, a great user experience in our app. But sometimes this cache is working against us and causing our users not to get the latest version of the app, which is probably because of a wrong cache configuration in our server. To avoid cache issues in our Angular application, we manage app versioning when we are building our app to production using ng-prod. ng ng build prod. So this is how we do it in the previous version, but now it's already ng build configuration production. So this one, to build this, you can add an option to use hash all thing, hash all something like that. But okay, so let's continue. Angular adds by default a hash to our JS files and updates our index.html. So what it does is inside your index.html, you have something like main.js to reference like all the codes that they put on the main. And because we put a configuration here, configuration production, it will add hashes into the code so that it will be main dot 1 2 e1 de2 da something like that, like a hash js. Okay, so when we deploy a new version, the hash keys are changed, and when the user asks the site again, the index.html will ask to load the new files from the server. Since the browser doesn't have those files in the cache, it will get them from the server. Okay, so what will happen there is, so this is your browser, and it's going to fetch from the server the files. So and for it will load the index.html. Oops, HTML, and it have a cache here. So a cache browser cache. So it will have the index.html, and it will have like main. This will include the main dot 1 2 3. This will be the hash dot h dot js. So it will include here main 123.js. Okay, and then this index.html is referencing this one here to load. So it will load it first, then put it into the cache, and the next time the user visits the site again, it will not go there and fetch the new file. It will just read here from the cache first. And so if those files here did not change, then it will just get it from the cache and not fetch it from not fetch a new file from the server. So if there's a new production release, let's see here, the green, it should be a green, right? Okay, so if there's a new version of the app, so there's a new index.html then it will generate a new hash. So this will be like a main.456.js. So it will then get loaded into the browser, the index.html. But since this index.html here is already cached, then it will try to read so it will get this index.html, and then since the files here already changed, so it's now 456, it will try when the user loads it and the browser tries to read main.456 and it didn't exist, it will pull from the server and get it to the browser, and then it will cache this main.456 so that this is the new version, and this one here, well, I'm not sure how this will be removed, but now our index should have this, and that should be the theory on it. Okay, so let's continue reading. When we deploy a new version, the hash keys are changed, and when the user asks the site again, the index.html will ask to load the new files from the server. Since the browser doesn't have those files in the cache, it will get it from the server, right? So that is what we explained. So it looks like Angular guys cover us. Well, not entirely. The problems are starting with the index.html file when the index.html file is cached. So yeah, that is my question earlier is so when this is cached and then it tries to read from the server, because we have a new version and it has new references, so 456, and the one that is cached is 123. What is going to happen there? So the problems are starting with the index.html file is when the index.html file is cached. Let's say we just deployed a new version of our app and the static files and index.html file with them are cached. In this scenario, when the user is starting to use our app from the main URL, he is getting the old version of our app because the cache index.html asks to load the old JS files. Yeah, so the cache here is still referencing the 1.123.js, not this one, because this one here is from the server, and then when the browser loads and it says oh, I have a cache of the index.html, it will load it will not get it from the server, and it will just get it from the cache with the old version of the files. Okay, so let's continue. As to load, okay, they'll probably load from the browser cache. Okay, so but let's move on with the scenario and complicate it a little. The user uses our app, remember the old version, moving between screens and doing some actions. We decided to refresh at some point, and now he is getting the new version of the app. Wait, the new version? But why? Index.html is in the cache. why are we getting the new version? So this is related to the redirect we are doing when serving SPA from a server. Okay, so SPA's handling the app navigation in the client side. So the client side here, index.html, this one here. Every navigation to a new route, Angular router changes the URL in the address bar dynamically. When a user types in the browser address bar a route of our app, say domain.com/home, and clicks enter, we actually don't have this route in our server, but instead of returning 404, we are configuring the server to return our index.html. So okay, so when we okay, so let's make this a little smaller. Okay, so when we, for example, we have our URL here, x.com/home. If we load this, this one does not exist in the server, so it will, what is happening again? Yeah, so when we load this, when we click enter, it will, instead of returning 404, we are returning the same index.html. So yeah, that is what happens, like if we are serving in the Angular SPA applications, the 40, instead of returning 404 for not found, we are returning index.html. So that is a common practice. So the Angular router is doing the job and redirecting the user to the right screen. Okay, so I didn't know that every time you enter this one here, it will still make an HTTP request. Yeah, we'll have to, why does it work like that? I will have to check the network tabs. So I didn't know that. Okay, so Angular, yeah, maybe I know that, but I didn't like think of it a little deeper. So Angular router is doing the job and redirecting the user to the right screen. Okay, now we can understand what is going on in our scenario. If we enter our app from the main URL, we are getting the old version. Since we have this, okay, so if this was as the main URL, we are getting the old version. Okay, and since we have this endpoint in the server, the browser can cache it. So so on here, the browser will cache it, or index.html caches it. But if we are asking for a route, we will always get the index.html from the server. Okay, and not from the cache. So we will see the new version after refresh. Okay, so if we route, so from here, if we load this will, so let's take a note of that. If we load x.com/route, it will fetch the new version from the server. Okay, it's a nice point. So nice, isn't it? And it's all because of a one index.html in the cache. How to check if index.html file is cached. So it's pretty easy to find out if the index.html file is configured to be cached or not. Open the browser DevTools, go to the Network tab, ensure the Disable Cache Index is not marked. Okay, it's not marked. Okay. Filter the doc, refresh the screen, click on the first document, check the cache control header. Let's take for example the angular.io doc site. So okay, can you do DevTools in iPad? DevTools, okay, Angular. See if we can do. Yeah, you can do DevTools, I think. Let's go to Chrome. Inspect element. Yeah, you cannot. Developer. No, right. Yeah, no. We cannot do it. Okay, so let's continue. We can see that the cache control header is no cache. Which values, no cache here, which values in the cache control header are good for us and which are not. So which values in the cache control header? This is the cache control header are good for us. No cache. This will cache our index.html file. But tell any cache system to check if there is a new version in their server. We're okay with that. Okay, no store. This will tell any. Okay, so no cache. No cache. Cache control header. Okay, this will cache our index.html file, but tell any cache system to check if there is a new version in the server. We are okay with that. Okay, so it will check. It will check for new version in the server. This will still cache our index, but it will check the new version in the server. Okay. No store. This will tell us cache system not to cache the index.html file. Also good. Max age 0. This also won't cache the index. Good. This one, the max age 3153600. This isn't good. Where is that? The value in the max age represents seconds for our index.html will be cached for a year. It's really up to you which values are okay by you, but I think we can agree we don't want the index.html in the cache for a full year. So I think this one here is preferable. It will still index, but it will check for the new version. Okay, those are the popular values for the cache control header. If you see something else in your response, you can check it out here. What if we didn't supply the cache control header? Well, now you are in a no man's land territory. This is a raw code from w3.org section 13.2.2. Since origin servers do not always provide explicit expiration times, HTTP caches typically assign heuristic expiration times. Employing algorithms that use other header values, such as the last modified time, to estimate a possible expiration time. The HTTP 1.1 specification does not provide specific algorithms, but does impose worst-case constraints on the results. Since heuristic expiration times might compromise semantic transparency, they ought to use continuously, and we encourage origin servers to provide specific expiration times as much as possible. Nothing there that I understand. Okay, so at this point, it will be nice to mention that there are few types of cache. The cache in our browser is our private cache because it serves only us in our browser. But there is a public cache shared between users with many possible. But there is a public cache shared. Okay, so let me read this again. There's, but I mentioned there's a few cache. The cache in our browser is our private cache. Okay, so we understand that already. But there is a public cache shared between users with many possibilities: proxy caches, gateway caches, CDN, reverse proxy caches, and load balancers. Yeah, so this is what I'm talking about, that some of my team did not understand, and I also did not understand what I'm talking about. But yeah, there is a cache in the browser, and there's also caches in the server, like gateway caches, load balancers, proxy caches, so something like that. Okay, so we understood that there is no specification for caches how to handle a situation where we are not supplying specific orders how to cache our index. Okay, so let's read this again. We understood that there is no specification for caches how to handle a situation. Okay, yeah, you cannot do specifications how to handle whatever scenario you want or whatever situation you have. Okay, where we are not supplying specific orders how to cache our index. Okay, so basically every cache or browser can apply its own algorithm based on some other headers we may or may not supply and still cache our index.html. More than that, you can't test those kinds of things. Your users may enter your app from private networks or even ISPs that apply some cache algorithms. Okay, so even ISP has cache algorithms. Okay, and you won't even know about it. This is the reason W3 recommended we provide explicit expiration time. Okay, so we should provide explicit expiration time. Okay, so make sure your index.html comes with the right cache control header. So always make sure cache control header. All right, so we should have that applied. Okay, so cache trap. The real problem with cache index.html is that users who already got the file in the cache are trapped in the cache file until one of those will happen. One of the two will happen. They clear the cache manually, assuming the file is cached in the browser cache. So yeah, so as I mentioned, there's different caches. So cache from the other things and cache browser cache. So yeah, so they need to clear the cache manually. So that you already got the file in the cache, are trapped with the cache file. Yeah, so the real problem with the cache index.html is that users who already got the file in the cache, so it's already file. So like what our example here, if the index.html is already in the it's already in the cache file, it's already trapped. So that's why you need to put a expiration date. Did we put it here? Yeah, so expiration time because of trap, because it's already trapped. Okay. So you can relax, those index.html issues are quite rare. Most of the hosting services won't serve the static files with long cache configurations as default. You may have the issue if you serve your Angular app from a server that already exists and serves dynamic files. What? If you serve your Angular app from a server that already exists and serves dynamic files. How to prevent index.html form from being cached? Okay, you will probably find some Stack Overflow's answers that suggest you try to control the cache with an HTML meta tag. You may even test it, and it may even work in your browser, but if you research a little more, you find this is not an effective way to prevent cache. Those tags may be honored by some browsers but not honored by other types of caches. The best way is to set the cache control header of your index.html from your server. Doing this requires some changes to your server configuration, but this is straightforward the most effective way to prevent cache. I have service worker, I'm all good. No, okay, so I'm not sure with service worker, I have not totally implemented this. Okay, so you may have noticed in the example from angular.io that the file served from the service worker, but you may have noticed in the example from angular.io that the file served from the service worker, but Angular guys still send this file from the server with a cache control, no cache header. Oops, my son already woke up. Okay, so service workers are awesome. They give us front-end developers full control while caching our files, but as we mentioned before, there are few cache types. Service worker is just one of them. The service worker is one layer your request is going through, but it's not replacing HTTP cache, browser cache, and of course not the public cache. If your service worker decides to get a file from the server, the browser will still check the relevant headers to decide whether to serve it from the cache or not. Okay, the browser will check the headers. The browser will check the headers first. Okay, some conclusion. Some cache issues are pretty hard to debug and reproduce and easily mistaken as code issues. They usually come from the end users of our app and depend on how frequently we are releasing a new version. Some users won't even report that they have a problem and will just describe it as a weird behavior that disappears when I refresh. We all want the best experience for our users. If you are not sure, then check your cache today. Okay, so we learned a lot from that. So now we are going to read an article for Angular rookie mistakes, how to cache bus an Angular 2 class application in production. Okay, so we'll keep this notes. We'll have this a little smaller again so that we can take notes. Okay. Typical problems. Angular app changes are not getting reflected on production. Angular app is not loading anything on production after a few release. My Angular app is always loading the older app files. Okay, so we already experienced that. So for another example, in the most recent release, you changed the API endpoint URL for fetching the log in users information. The new app has those changes all tested and great, but the support team has been receiving complaints ever since the new release that the app is not working at all. You figure out that the hold on. The app has those changes all tested and great, but the support has received blah blah blah. Okay, cause the issue is quite simple: browser cache. The client browser has also cached the app's index.html file along with other static files or source files like images, CSS, JS files. However, caching index.html means that the script blah 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 inside are also old, still pointing to the old JS and CSS files since the issue. Okay, so you have to set the cache control headers on index.html file before it's served. This informs the browser to always request for index.html from the server and never cache it locally. Okay, so if you are a web developer, you must be knowing at least one technique to set HTTP headers in the language of expertise. Setting HTTP cache headers on static files, however, are typically but not limited to done by web servers or dynamic proxy request handlers. For example, on IaaS hosted applications, you can do this by adding the following to your web.config. Okay, cache control, no cache. Okay, so unfortunately for users who already opened the app recently, there is no direct way out but to ask them to clear your browser cache. You could try hack your way through this problem for these users, but that is out of scope of this article. Maybe I can try covering that in a different post if people are really interested in it. Okay, so this is the solution. We just need to do the cache control settings, and for those users, so for example this user here using the browser, using the phone, so they have their caches, and this is our server. So when they fetch the website, it will be cached. Index.html is cached, and then and this is without the cache control yet, right? Cache control. So when we deploy a new version to our, this is version 1, okay, so this is version 1. So if we deploy a new version, version 2, the problem here is they will not take version 2 because they have cached it here, so they're still viewing version 1. So this version 1, so they have to refresh, clear the cache so that it will get the new version of version 2. But if we, for example, if we say, okay, so in version 3 we want to have the cache control already, we want to set the cache control. So but so we have other users here. So this one here is a fresh new user, so it doesn't have any cache yet. So when they visit our website, the browser here will be will be instructed by the cache control header to always check the cache control if they're going to serve from the cache, or if they're going to get it from the server. I think, I'm not sure. I think I lost my thought there. But yeah, so this one here, it doesn't have any cache. So this one here will always have v3, and then if there's v4, this guy here will not have any problem, so he will have v4. But for those prior have the index.html cached prior to v3, yeah, they will have a problem. They still need to have the cache cleared in their browsers so that they can like have the updated cache control here on the index.html. All right, so I guess that's the summary of it. Cache problem during deployment to production with service worker. I think this is not related to what we are researching. So yeah, that's all, right? So I will have to take care of my son. All right, thanks. Bye.